Welcome to Future Dr. NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 1, electric charges and fields. Let's move to question number 1. An electron is moving around the nucleus of hydrogen atom in a circular orbit of radius r. The Coulomb force F between the two is dash. What's the formula for Coulomb force? F equal to K into Q1 into Q2 by R square. And electron moving around the nucleus. So Q1 equal to electron charge is minus E. An electron, one electron, so minus E. And Q2 is one proton, that is plus E. Substitute this. Then F equal to minus E into plus E minus K into E square by R square. And this is a vector quantity. Okay. And introduce unit vector as r cap. And we know unit vector r cap equal to, what is the formula? What is the formula for unit vector? That is r cap equal to vector divided by its magnitude. So r vector divided by its own magnitude. Then if you substitute this here, then F equal to minus K E square r vector divided by r square into r cube. Which option? Option B. Option B is the correct answer. Let's move to question number 2. When air is replaced by a dielectric medium of constant K, the maximum force of attraction between two charges separated by a distance is dash. Formula, that is F equal to 1 by 4 pi epsilon naught into Q1 into Q2. This is for air medium. Force of attraction in between air medium. And in between, after introduction of dielectric medium, I'll keep as F dash. F dash equal to 1 by 4 pi epsilon or epsilon naught. But epsilon naught is a dielectric constant. Instead of that, K is given. So we will use 1 by 4 pi epsilon naught K into Q1 into Q2. Then F dash by F equal to Q1, Q2, 4 pi epsilon getting cancelled. Then 1 by K only we will get 1 by K. That is F dash by F equal to 1 by K or F dash equal to F by K. F dash equal to F by, that is K is in denominator. Therefore decreases K times. Option A is the correct answer. Let's move to question number. A pendulum bob of mass 30.7 into 10 power minus 6 kilogram and carrying a charge 2 into 10 power minus 8 coulomb is at rest in a horizontal uniform electric field of 20,000 volt per meter. The tension in the thread of the pendulum is dash. Formula is tension T equal to two forces are acting, that is force due to weight, that is W, plus force due to electric field as Fe. Let's find separately weight. Weight W equal to, what's the formula? M into G. And M is given 30.7 into 10 power minus 6. 30.7 into 10 power minus 6 into G. G 9.8, or we can keep 10. Then W equal to 300 into 10 power minus 6. We can write this as equal to 3 into 10 power minus 4 Newton. Okay. And force due to electric field. What's the formula? Force due to electric field equal to Q into E. Q into E. And Q is, what's the value of Q? 2 into 10 power minus 8. 2 into 10 power minus 8 into E. 20,000 or 2 into 10 power 4. Then you'll get Fe equal to 4 into 10 power minus 4. Newton. Substitute this here. Tension T equal to square root of W 3 into 10 power minus 4 plus 4 into 10 power minus 4 whole square. Yes, I missed the square. Whole square. This is square and this also square. Then 10 power minus 4 whole square. And if you take square root means into 10 power minus 4 and 3 square 9. 9 plus 4 square 16. That is square root of 25. That is 5. So tension T equal to 5 into 10 power minus 4 Newton. Option C. Let's move to question number 4. An electric dipole of moment P is placed in an electric field of intensity E. The dipole acquires a position such that the axis of dipole makes an angle theta with the direction of the field, assuming that the potential energy of the dipole to be 0 when theta equal to 90 degree. The torque and the potential energy of the dipole will be dash. Torque formula tau equal to P E sin theta. Tau equal to P cross E and P cross E equal to P E sin theta. Next, potential energy. Potential energy U equal to integral of tau into d theta. Okay, tau is P E sin theta. Therefore, U equal to integral P E sin theta into d theta. And this theta value change from 90 degree to 0. 90 degree to 0. Then I'll write this here. U equal to PE into PE constant take out of the integration. Integral of sin theta d theta is minus cos theta. Then minus PE into cos theta. Cos theta, substitute upper and lower limit as 90 and 0. Then cos 0 is 1. Cos 90 is 0. Then minus PE into 1 minus 0 as just PE cos theta. This is your U. U equal to this one and tau equal to this. Which option? Option A. Option A is the correct answer. Okay. Let's move to question number 5. A point Q lies on the perpendicular bisector of an electric dipole of dipole moment P. The distance from Q from the dipole is R. Then electric field at Q is proportional to dash. That's the formula for electric field due to a dipole when it is at a equatorial line. That is E equal to formula Q by P by 4 pi epsilon naught R Q. From this E depends upon P. E is proportional to P or P power 1. And also E is inversely proportional to R power 3. This you can written as E is proportional to R power minus 3. So E depends upon P and R power minus 3. That is option D. Let's move to question number 6. Two parallel infinite line charges with linear charge density plus lambda coulomb per meter and minus lambda coulomb per meter are placed at a distance of 2 or in free space. What is the electric field midway between the two line charges? Formula, that is E equal to lambda by 2 epsilon naught R. That is the formula, 2 pi epsilon naught R. Lambda equal to 2 pi epsilon naught R. 2 pi epsilon naught R. Okay. And for plus lambda E1 and another lambda also E2. E2 equal to, because 2R from middle means R by 2, 2R by 2 is R. And E2 also lambda by 2 pi epsilon naught R. Okay, sixth question. Two parallel infinite line charges with linear charge densities plus lambda coulomb per meter and minus lambda coulomb per meter. This is minus lambda coulomb per meter are placed at a distance of 2 or in free space. What is the electric field midway between the two line charges? Formula E1 equal to lambda by 2 pi epsilon naught R. And E2 also equal to lambda by 2 pi epsilon naught R. And this is a diagram. This is a plus lambda and this is minus lambda. Separated by 2R distance. 2R distance. So middle means this is R. Both the side is R. What's the direction of electric field? Direction of electric field E1 is acting in this direction. E2 also acting in same direction. This is a E1 and E2 also acting in same direction. Then net electric field equal to E equal to E1 plus E2. E1 plus E2. So just adding lambda by 2 epsilon naught R plus lambda by 2 epsilon naught R. 2 pi epsilon naught R plus lambda by 2 pi epsilon naught R. Then E equal to 2 lambda by E equal to 2 lambda by 2 pi epsilon naught R. And here 2 getting cancelled. Then E equal to lambda by pi epsilon naught R. lambda by pi epsilon naught r, that is option B is the correct answer. Let's move to last question. A hollow insulated conducting sphere is given a positive charge of 10 microcoulomb. What will be the electric field at the center of the sphere if its radius is 2 meter? Formula, that is E dot ds, that is a Gauss law. E dot ds equal to Q by epsilon naught, that is 1 by epsilon naught times the net charge enclosed, and this charge Q is inside, Q inside. Then Q inside is 0 because no charge, that is when the, what will be the electric field? The center of the sphere. Inside a sphere, there is a sphere, and what is the electric field? At the center of sphere means inside no charge enclosed. So Q inside is 0. Q inside equal to 0. Therefore, E dot ds equal to 0 or E equal to 0. That is option A. Option A is the correct answer. Okay. Thank you, students. In next session, we will see through next chapter in problem solving session. Thank you.